All right, hello ladies and gentlemen, welcome to 10-2. We're kind of taking a different direction with exponents, talking about logarithms. Logarithms basically kind of undo exponential functions, so you need to be able to evaluate, solve equations, and solve inequalities dealing with logarithms. So let's kind of take a look here. So if you have y to the 2x, that would be a exponential. You should recognize that. We talked about that yesterday. So now if I flip it, so now if I get x equals 2 to the y, that's also going to be a function because exponentials are 1 to 1. So if you look, all you need to do to graph the inverse would be to swap x and y. Okay, so here, you have -3, 1/8, then when you flip it, it's 1/8 -3. So this one would be your y to the 2x. This one would be x to the 2y. But notice, it's perfectly symmetrical about the line y equals x. That's this line right here. That is this green line right here. That's y equals x. So it's perfectly symmetrical about that. All right, so it's kind of the inverse of a quadratic. So a logarithm is just that. It says a logarithm with base b, and it says the inverse of y equals b of x is x equals b of y. This is called a logarithm. So it's written like this. All right, so log base b of x equals y. All right, so it's like saying b. So it's like saying b to the y equals x, which is this thing. So this is kind of what it said. Log is just there to say, you know what, this is going to be an exponent. Let's take a kind of look at what I'm saying here. So what this is saying is that this is saying 8 to the 0 equals 1. Okay? So this is my base. This is the exponent. This is my answer. This is what it equals. So for b, that's going to be 2 to the -4 equals 1 over 16. And that should make sense. 2 to the -4th is 1 over 16. And here, this is going to be 4 squared equals 16. So there's my answer, there's my answer, there's my answer. So that's exponential form. So now, flipping it around, this is going to be log base 10 of 3. I'm sorry, back up. Log base 10 of 1,000 equals 3. So this is going to say log base 9 of 3 is going to be 1/2. And this is going to say log base 125 of 5 is going to be 1/3. So that would be in logarithmic. So here, you've got base, you've got answer, this is your exponent. Okay, and they work backwards with exponentials. So let's take a look here. So if we've got 2 to the y equals 64. So basically I want to know what 2 to what power gives me 64. Well, 2 to the y, 64 is actually 2 times 2 times 2 times 2 times 2. I believe it's 2 to the 5th. Nope, I was wrong. It's 2 to the 6th. So that means y is going to equal 6. So here I've got 3y equals 81. So 3y, 81 is really 3 to the 4th. So that means y equals 4. Down here you got 4 to the 256. So you got 4y equals 256. So 4 raised to the 4th is going to be 256. So I'm going to get 4y equals 4 to the 4th. So y will equal 4. So you're looking for the exponents that match those up. That's all you're looking at, really. So a couple things about log functions. They are continuous, 1 to 1. Domain's all set of positives. Range is all set of reals. Y-axis is an asymptote. Contains a point 1, 0. the x-intercept is 1. So b has got to be greater than 0, and b cannot equal 1. B cannot equal 1. I'm hoping that makes sense, because 1 raised to any power is just going to be 1. So it's got to be bigger. It cannot equal 1. All right, so let's take a look here. So what this is saying is this: 4 raised to the 5/2 power equals n. So now what this is saying is take the square root of 4 to the 5th, and that equals n. So 4 to the 5th is going to be 32, or sorry, 4 to the 5th is going to be 1024. So then when I square root that, n will equal 32. There's my answer. Okay, so notice, this is your power, this is your root. That's the rules from exponents. So log of 9 of x equals 3/2. So this saying x to the 3/2 power equals x. So this is saying take the square root of 9 to the 3rd. So when I do that, I get 2 squared times 729. So when I square root that, it's just going to be 27. There's my answer. But notice, the most important part of here is the setup. So here, a little tougher, b squared equals 121. Well, hopefully something jumps out at you that, hey, 121 is a perfect square. So if I square root both sides, b has got to equal 11. There's my answer. So, couple switching gears here, inequalities. So anytime you're dealing with inequalities, you got to be careful what's going on. Here's kind of an example of what might help you. If it's going to be greater than, then x is going to be greater than your function. If it's going to be less than, it's going to be less than your exponent, but it's got to be greater than 0, cannot equal 0. All right, so here's kind of in general form up here. X equals b greater than y, or x is less than b to the y, but greater than 0. So if it's less than, like this one is, what I want to say is this: x will be less than 5 squared, but bigger than 0. So 0 will be less than x, less than 25. There's my answer. So that's what I'm looking for. So here, it's greater than, so I will say x is greater than 4 to the 3rd. So 4 to the 3rd is going to be 64. There's my answer. Likewise here, x is going to be less than 2 to the 4th, but it's got to be bigger than 0. So it's going to be 0 less than x less than 16. That is my answer. So take a look here. You got logs on both sides. But the very, very nice thing is that it is the same base. So this is the equivalent of saying x squared minus 2 equals x. Now it becomes a matter of how are your algebra skills? So x minus 2, x plus 1. So x equals 2, or x equals negative 1. I'm going to say that that's probably my answer, because that has got to be bigger than 0. So I'm going to say x equals 2 is my answer. Likewise here, x squared minus 15 equals 2x. You know, the logs, I hate to say they cancel out, but it kind of works out that they do like that. So I have x squared minus 2x minus 15 equals 0. So that's going to be x minus 5, x plus 3. So x equals 5, x equals negative 3. Negative 3 gives you a negative number here, so I do not want that. So I'm going to go with 5. So last one, x squared minus 30 equals x. Like, again, the log of 14s basically cancel out. So now it becomes a matter of factoring. So if I bring this over, x minus 6, x plus 5, so solved, x equals 6, x equals negative 5. I'm going with the positive answer. There's my answer. All right, come talk to me with questions, playing around with this, and we'll talk to you soon. This should actually be 10.2. All right.